What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovi, and this is the tutorial series where we're making your game. So, here we are, looking at our beautiful to-do list. Woo! We already took care of this improved movement thing. Now, there is some stuff that I want to do with the enemies, and maybe speed up the bullet speed, I think I said. Anyways, we're going to do those two things. As I said before, the sound effects and the music, I am going to wait till we have somebody to feature on our channel, yoo-hoo, for the sounds and the music, or the music maybe. So I'm going to just move that down, all the way to the bottom. If you really want those to be done, just so because you want to learn how to do it, well, let me know. We can always put in some placeholders instead. So, and if you have any other ideas, drop them in the comments so that I can add them to the list. It's gonna be really great. So we're gonna start making progress on this multiple enemy types. So first thing, what I wanted to do is I wanted to speed up the bullets a little bit. So as you can see, I'm looking at my local constants up here and I don't see a bullet speed. So we're gonna actually go ahead and make that constant right there. We're gonna do local speed bullet max, open brackets const, close brackets equals. Oh, look at that. We're setting the velocity from the player. How stupid. So instead of creating the speed bullet max here, we're gonna go ahead and put that in the player. Right there. And I saw that we had some nice comments over there, so we're gonna say local constants. We're gonna add one above here, which is assets. And we're gonna do local variables. And I'm gonna do local slash static, because it means that basically there's only one instance of the class, which there's better things to do in terms of that, but we can leave it like that. So it's angry because I haven't put in a speed. Let's go and get this bullet speed. Bullet spawn, val x, val y. So it's 7.5. That's the bullet speed. You got it right there. So let's call it speed bullet max. And we're not going to do 7.5. We're going to speed it up a little bit. Let's try 10. Let's see how that goes. Press A to start. Boom. It's slightly faster. Honestly, I'm going to put it faster than that. Do 13. Lucky number. Ooh, all right. I like the speed of that bullet. It's way more like an actual bullet. Boom. Oh, we still have a bit of a despawn issue. I just saw. Yep, I just saw some despawning for no reason apparently. Okay, we'll have to take care of that at some point. All right. So bullets are faster now. Great job, everybody. Big success. Great success. And let's go ahead and improve this enemy class. So the enemy class thankfully is already pretty small, so we don't have any problem there. So spawn rate per take, 0. Almost 0, let's say. Of course it's not actually 0. Speed equals 1. So let me describe to you guys what I want to do. I want to make this sprite that we currently have, our little ghast. Maybe we can add that as a sound effect when they spawn. I want to actually make them move towards you, kind of like jellyfish, like whoop, move towards you, whoop, move towards you, like, you know, in a basically so that they localize you once and then they move, and then they localize you and then they move. And so again, we're gonna have an acceleration part of it, so they're gonna move fast and slow down and fast and slow down. And then there's gonna be instead of finding you every tick, they're actually just gonna identify you once and then move. And then once they're done moving, they're gonna find you another time and then move again. So we have a few tools at our disposal from the PlayDate SDK. We have stuff like animators. We have stuff like timers. So I'm not yet sure which one we're gonna use, but let's get right into it. So the speed, let's see what's going on right now. So basically right now we're getting the player instance, and then if he didn't die, sorry, then we move towards the player, and then if not, then it doesn't matter. So that's great. Oh yeah, this was the Genius Da Vinci line. If you don't remember, I hope I don't need to remind you. Go back to the episode. Remember who I am. So instead of doing this, oh crap, I've got 3% on my battery. Pause. All right, guys, we're back. So I did get to play around a little bit in the meantime and figure out how to do this stuff. So now that my phone is charging while recording, genius idea, I can go ahead and show you guys how to get the enemy to move in this particular way. So we're actually going to use an animator. So PlayDate animator. Let me show you guys inside PlayDate. All right, so here inside PlayDate, and we're going to look up the animator. So basically the animator, the way it works is that you give it a start value, an end value, a duration, and it will, every tick, it will update its value. Well, it technically doesn't update its value. Technically, it uses the current time to calculate its value. So it's pretty clever. And then you can actually give it an easing function, which is going to be basically whether you want it to start slow or to end slow or to start and end slow. And there's this nifty website that's also linked inside the documentation. If you click on easing functions anywhere, so playdate.easing functions, you'll see this is the full list, which might feel a bit overwhelming, but actually they're relatively simple. And there should be this link. This page right here does a great job. So that page is this one here. And you can see that basically, well, of course, excluding like linear, which is literally start, maintain, and end at the same speed. There's all these different parameters of like ease in. You can see that at the beginning, it starts slow and then it speeds up. And so sine is like the closest to linear that you can get, ease in and out. We're more interested in something like this, ease out, ease in, out, cubic. Same thing with like, you know, quint, circular. So these are just like parabolas, like whether they're cubic, quint, etc. Same thing with quart, exponential as well. This is one I probably use most commonly. And then you've got like funky ones that kind of go back a little bit, like elastic, and then balance as well. This could be useful if you want to do like a special animation, but in game, it doesn't really apply as much because usually you would have the physics actually doing the bouncing for you. Anyways, we're going to use one of these. It's just wanted to point that one out for you guys. So if we go back slightly to the animator, so we've got the duration, start value, end value, easing function, which we just reviewed, and then the offset in case we want a little bit of delay before starting it. So the way we're going to do this, we're actually gonna, so we have a few things to change over here. So it's going to be this one, where instead we're going to actually only get the player location and set the movement when the animator is finished. So we're going to do if self.animator movement, that's what we're going to call it, then instead of end, we're going to do else, and then we're going to put that code in which was there before with get the player until the move by, and then the end after that, and we're going to add another end. So basically, if there is the animator movement, then we move according to the animator. If not, then we get the player, and then we actually set the animator. So, so what we're going to do, we're going to rename target X and target Y to player X and player Y. And in fact, you know, while we're at it, let's rename it to X player, Y player. I know if you don't want to, you don't have to, but I'm going to do it. And then player Y, you see how Y player, and then X player, and then here we're going to do X target and then Y target. So this is actually going to be the target of our movement, and so instead of moving player, we're going to actually set the animator. So it's a comment, set the animator to target point. So we're going to do self.animator movement equals gfx.animator.new, And so now we need multiple variables. So we're going to have the duration. We're going to have the movement. So we're going to put duration as 800. So that's 800 milliseconds. In fact, I think we're going to do more. We're going to do 1,800. I'm going to go ahead and go down to the initializer that we want to use, which is start value and end value. And as you can see, we can give a number, but we can also give a point. And that's what we're going to do. We're going to do GO, which we don't have. So let's add GO to the top of the file. Local GO, open close brackets, const equals playdate.geometry. And so we're going to do geo.point.new, and we're going to start at the self.x and self.y, and we're going to do another geopoint.new, and this time we're going to do self.x plus x target, and then self.y plus y target. And then we've got an easing function and a start offset, but for now we're just going to leave it like this. We don't need to actually go into that detail. So now that we've set the animator, we actually need to move the player, the enemy, towards the animator, or towards the destination of where the animator tells us to go. So what we're going to do is that we're going to say local x, y equals self.animate. Oh, sorry, no, this is not x, y. It's actually just, you know what, let's just do that. Current value, so however, this is going to be a point, geometry.point. And so what we want to do is we want to unpack that point into an x and y. He's complaining. So let's actually, we're not going to unpack it directly. We're just going to say point destination right there. So that's going to be where we want the player to go that tick. And then we're going to do self : move to point destination.x, point destination.y. There we go. So now for some reason it doesn't complain anymore. And then there's one more thing to do, is that if the animator is ended, so we're going to add a line after that saying if self.animator movement : ended, open close brackets, then self.animator movement equals nil. There we go. So this is actually going to cancel the animator at the end. And then because the check here will detect that the animator is empty, then it's going to create a new one, basically. So, ready to test it, guys? Let's go. Start. Woohoo! Nothing moved. You know what? This happened to me when I was giving this a test round while my phone was charging. I'm actually going to go in and do... What it is that the speed is 1. So technically every 1.8 seconds, it's moving like 1 pixel, which is a bit sad. So we're gonna go ahead and move some constants up here. So we're gonna say local constants. We're gonna have the speed, which is like the speed movement, just to be clear. I'm gonna say like 28. Then I'm gonna say local duration movement, open brackets, const, close brackets, equals 1,800 as we put before. And then I'm gonna say duration, local duration, movement delay, open close brackets, const, you get what I mean. And I'm gonna put, I don't know, 300. So I'm actually gonna add a delay in between movements. So we're not gonna use it just right now, but let's try it with the speed first. So speed movement, I'm gonna replace the line 48 where you have x target, y target equals get rotation components, and I'm going to use speed movement right there. And then inside the gfx.animator.new, I'm going to replace it with duration movement. And then we're going to be able to add movement delay, but in order to do that, we need to also give him an animator easing function. So we'll see that in a second. Let's restart the game, press A, and you can see that he's moving very smoothly, which is sort of like what it was doing before. So that's a bit mysterious of why, if anything, changed. So let's give him an easing function and we'll be able to see what changed. So at the end of the gfx.animator.new, so we've got the 2 geometry points and the duration. We're going to add a comma, and you're going to see that, sorry, this initializer doesn't know what we're doing. We're going to see that it asks for an easing function. So in order to do that, we're going to do playdate dot easing functions dot, and then we're going to do out expo. So that's going to start fast and then slow down, kind of like boom, boom, like that. And then here we can actually give our delay. So we're going to say duration movement delay. So now we've got all our arguments in the animator function, and we're going to see how that looks like. Yoo-hoo! Got our little jumping guys. Now the delay is a bit long. So what we could do is actually reduce the delay and the duration so that they move faster as the difficulty goes up. We could do something like that. Let's see, where's spawn difficulty? Let's see, utils difficulty, get value. Problem is I forget how the value is. It's a value of 1 that goes up. So what we could do is movement delay, duration movement. So let's do it like this. And I'm adding this just to have fun, guys. So let's get the difficulty value. So at the top of enemy colon update, we're going to do value difficulty equals difficulty with a capital D, so that we're referring to the class, dot. So actually we're going to need to do a colon. So actually let's see where the difficulty is being used. Yeah, okay, so the difficulty is being used in the main.lua. So thankfully we do have time today, so let me get into it. I'm gonna teach you guys really quickly how to do a static instance of a class. So what does static instance of a class mean? Well, in the case of our enemies, let's see. In the case of our enemies, you can see that we have like 1,000 of them hanging out. And so basically this class that we're using is a blueprint for every single one of these enemies that we have. Meanwhile, when you look at the player, we're still using a class to instantiate the player, but there's only going to be one player. Like, unless we add local multiplayer, and good luck with that, which of course you can if you want, but in that case, like, the static doesn't really work. Let's take an instance, for example, the menu. Like, we don't have a menu class yet, but you can see the spaceship, press A to start. Like, there's only one of those. And maybe for the human as well, maybe for the game instance. And in this case, the difficulty class that we have is actually a static thing, because the difficulty just goes up. We're not managing multiple difficulties at once. So this kind of difficulty manager actually makes sense to make it into a static class. So there's only one, and what we want that to be as like the outcome is basically going from enemy class, and every enemy can grab the difficulty at any moment. So instead of doing local value difficulty equals difficulty, and like instead of creating a new one and managing it separately because we don't have all the parameters, what we would expect is to do something like this: difficulty dot get instance, open close brackets, and then that's your instance. It's like if I did player dot instance, or I guess it would be cleaner to do get instance, just so that we theoretically can control whether there is an instance or not. Here you can see that we just did instance. So let's change the player really quickly to make that a bit cleaner. Where is our instance? Yeah, you see that we just put it right there. I guess that's one way to do it. Like, Lua is very flexible. Another way to do it is to actually control the instance within the class. File, I mean. So let's do that. Static instance. So I'm going to do local underscore instance. So I'm inside player class right now. And I'm right underneath the class player. I'm actually going to do this static instance thing right here. And it's going to be nil to start with. And then in the init function, I'm actually going to do instance equals self right there. So now the instance is no longer accessible through the class, but I can add an accessor with the class. So after player colon init, and actually I can do it underneath the instance. Underneath local underscore instance, I'm going to do function player dot, not colon, we're going to do a class function, static one. It's going to be player dot get instance, capital I. And then here we're going to do return underscore instance, and then end. So that's going to be our function to get the player instance at any moment. So let's check in our project. whether we have player.instance being used anywhere. Okay, so we have the spawner and we have the enemy. So let's get the enemy one first, the one that we saw before. I'm going to go ahead and replace that with get instance. And then I'm going to go into the spawner and I'm also going to replace the instance with player.get instance right there. All right, and then we should be good there. Now I'm going to add an instance, exactly the same pattern, to difficulty. So I'm going to do static instance in a comment, local underscore instance, and then function difficulty dot get instance, open close brackets, return underscore instance, and then we're going to set that instance inside the difficulty colon init. So we're going to do instance equals self. So again, here, like, we could add extra checks. Like, for example, if there's no instance, then we throw an error. We could do a check like if there's already an instance and we're initializing it again, then it complains. And basically doing this pattern allows us to extract some variables out of the class and into the file local scope, which allows us to actually accelerate the process of these different values slightly. Let's just say that instead of getting a table and then getting the value from that table, we have the value directly, and it kind of speeds up the game. We're not going to do any of that right now. We're not really doing any optimization, but it's nice to have it in case you have a lot of utility classes that are being used frequently. It makes a lot of sense. Yeah, so okay, let's go back to our enemy class. So we have this player instance. So sorry, we were doing value difficulty. So let's go to the top of enemy colon update, and we're going to do local value difficulty equals difficulty dot get instance. And we're actually getting the value. We're not getting the difficulty manager. So we're going to do get colon get value at the end of the get instance. So that's going to be our difficulty value. Then we're going to do, so actually we don't need to do that at the top of the update. We can do that directly inside the animator creation block. So when we're doing the calculate path to player, we're going to have the speed over here, but actually what we want to modify is the animator to be shorter. So we're going to do get difficulty value, and we're going to paste that line there, local value difficulty equals difficulty dot get instance colon get value. And then we're going to do local duration animator equals duration movement divided by value difficulty. So our difficulty value is going to be at 1 and it's going to go up. So to start with, it's going to be relatively the same as 1, so it's not going to change. But over time, they're going to start to move faster and with less delay as well. So we're going to do the same thing, duration animator delay equals duration movement delay divided by value difficulty. And then we can replace those two values in the animator's initializer, the .new function, with duration animator as the first one. And then at the last argument, duration animator delay. All right, we're ready to run this. Let's hit restart. And oopsie. All right, let's see. So you can see that for now they're moving relatively normally. I'm just gonna survive a little bit. Hold on, where's Buggy? Where's Buggy when I need him? All right. Ouch. All right. By the way, I do like how this game is feeling. We do need to add a bit more dynamic stuff, like, you know, actual reasons to move around and not just shoot all your bullets. But I think it's looking pretty good, honestly. So, all right, so I'm not really seeing the difficulty change all that much. But, you know, as you play, maybe it'll start to show up. Because in theory, we should almost be at, like, difficulty 2 by now. They kind of seem to be moving faster. Anyways, fast forward through this part. All right, in case you want to do a sanity check, well, you can do like me. So what I'm going to do is I'm actually going to click into the code out of the simulator. I'm going to set a breakpoint on the self.animator movement, and I'm going to click back into the simulator. And here you can see all the variables that are happening. So you have the value difficulty at 1.8. You have the duration animator at 952. So we're almost at 2 times the speed, because it used to be 1800 and now it's at 952. And then the delay is at 150 as well. So the good news is that the difficulty curve is gentle. So it does get more difficult, but not too fast because we haven't noticed it. The downside is that it's not directly noticeable, but maybe that's also a good thing. So I'm gonna go ahead and let myself get killed and restart the game and see the difference. So look how they're moving. Jump, 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 and we're gonna restart. Yeah, there's a difference. There's a difference for sure. All right, guys, that's gonna be it for today. Thank you guys for watching, and I will see you guys in... Drop your ideas in the comment section below the next one. Bye-bye.